Thank you so much for coming. So today my talk is about controllers because the day I started my journey in cloud native, I got used to so many controllers because almost every single project that I ever used was in itself a controller. So controller is like no big thing. It's like everything, almost everything, every project we see has an operator, has a controller behind it. So I really wanted to talk about it. I wanted to highlight the power of controller and talk about how it has actually done so much for the whole cloud native thing and extended Kubernetes beyond just Kubernetes. So before starting, a little about myself. I am a software engineer at Akuity. I am also a CNCF ambassador and a certified Kubernetes administrator. If you want to connect with me, there is a QR code right there. Oh, I'm also a GitHub campus expert, so which is basically like representing GitHub and being a leader for GitHub and things like that. So if you all are interested in any GitHub education benefits, it's something that I generally do. Now I would quickly take a brief of the agenda that we are going to go through today, which is why Kubernetes controllers are the magic glue of the ecosystem, of the CNCF ecosystem. And I would also go through the problems that Kubernetes controllers are solving, and we'll see a live demo of how you can build one Kubernetes controller very much easily without much hassle, and you can just keep building stuff, and maybe one day you'll come up with something that becomes in itself a big solution. And we will then have a quick dive into some of the project code bases who are using controllers internally. So yeah, before getting started, I'm quite nervous. This is one of my first technical talks, but I'm really excited and I'm really happy that y'all showed up. So the big picture about why Kubernetes controllers are the magic glue. So we know that in general, in Kubernetes, there is a misconception that Kubernetes is an API server. It's all about an API server because sometimes we often end up calling Kubernetes an API server, right? So people who are not very much into Kubernetes things, they don't know this, but technically a lot of people know that the Kube API server is sort of referred as Kubernetes. But do you know that Kubernetes in itself is a collection of controllers? So when I say that, almost everything that is managing Kubernetes on top is a controller, be it a node controller, which is basically managing the health of the nodes, replica set controller, which is ensuring that pods are correct, then the job controllers, which are running bad jobs and things like that. HPA is a controller, ingress controller, scheduler, which is again a special controller assigning pods to different nodes. And of course, not just this, we have custom controllers. So I think everyone who's working somewhere is familiar with some of the other projects in Cloud Native, which in itself is a custom controller, which is an extended version of controllers. Like what I have here is Argo CD, Cargo, Kiverno. These are some of the projects which are just giving extensibility to Kubernetes and extending the solution in general. So everything in Kubernetes is managed and controlled by controllers. What controller is doing is something we are already sort of familiar with. What happens if I delete a pod? So if I delete a pod, does Kubernetes know how to recreate it? Of course not. Kubernetes knows how to do things on top level, but controllers is what gives it the manager. So what keeps everything running very smoothly is a Kubernetes controller. So like if you see the diagram, the controllers are automating things. We define a desired state. A user defines the desired state, but maintaining that desired state is the job of a controller, as we know. So what controller does, like for example, here we have a replica set controller. What it does is it keeps watching the actual state, which can be mismatched, which can be correct. It always keeps matching it, checks if there's a difference, and reconciles, or what we call runs a control loop to make sure that the actual state is equal to the desired state. So that's a simple control loop that helps Kubernetes have the property of self-healing. That's one of the properties. Now, this is also, we know that controller follows a very similar flow or what we call as a loop, control loop, that is watch, reconcile, and act, which we also call as keep watching the resources that you have defined, and then reconcile, or basically check the differences between the desired state and actual state. And if there is a mismatch, then just act on top of that resource. So that's what we are doing here. We're observing the desired state, we are comparing it with the actual state, and then making necessary changes. And that's the job of the controller. Now, this feedback loop is what is making this particular system very reactive and self-managing. Like a user is defining the desired state, then Kubernetes API server is basically storing that desired state to etcd. And now, if there is any deviation, like you see that crooked box, controller will make sure that it is reconciled and presented to you in a correct form. Hence, Kubernetes is not just an API, is what was the context of these 5 minutes. Kubernetes can automate, scale, and self-heal because of controller. Controllers make them do all of these things. But now, done with all of these heavy lifting, what are the extraordinary problems that are solved? We know what Kubernetes is doing, but what ahead of it, right? So let's look at some of the real-world power of controllers that I am so amazed of, because almost every Kubernetes cloud-native project that I go around contributing has these controllers, and I'm so excited to see them and how the whole architecture is nothing else but a controller's architecture. So that's very cool. So about this, Kubernetes controllers, as we know, are the backbone of solving problems. And I think in next few slides, we will see and explore how these controllers are solving some of the extraordinary problems. But before that, do you know what happened if there was no controller in Kubernetes? A user would have basically applied their specifications or their configurations, and every time they apply their configuration, the Kube API server would have done its job, that is, store it in the etcd. But what if later on, who ensures that it is stored in the etcd in the correct form? Nobody. So maybe the user would have never come to know that the configuration that you applied is in the correct state. But with controller, the controller knows how to update you with the correct state of your specification and of your deployment. And with that, this is one of the internal things that Kubernetes is doing, the Kubernetes architecture that almost all of us are familiar with. And if you see, this is so much a collection of controllers in itself. The whole architecture is representing a controller. So if you see, there's a kube controller manager, which is basically the manager for the core clusters. Example, the nodes, the deployments, and the replica sets, job controllers, all of those stuff. Then we see there is a cloud controller manager, which integrates Kubernetes with cloud providers like APIs and load balancers and all those stuff. Then Kubernetes has a kube scheduler in its own internal architecture, which is not strictly a controller, but it is also sort of doing the same thing, which is scheduling and updating the pods. But let's get outside of Kubernetes now and see how controllers can be used outside of Kubernetes and how we can do more stuff. And that is where we introduce operators. So controllers are like control loops that runs against your resources, right? So controllers run against your resources, but operators runs custom control loops against your custom resources. So everything is now customized. Now it's all in your hand. You can define custom resources, which we call as CRDs, custom resource definitions, and controller, which is again your custom controller. You can define how you want the controller to automate things or how you want it to manage your deployments and everything. So you define a custom controller to run a similar control loop as Kubernetes was doing for itself in the core cluster, and that is how we move. Now, I obviously had to list all of these crazy projects that I've been looking at, I've been contributing to. So these custom operators are almost everywhere in cloud native. Like all of these projects are at some point using these custom operators and are built on top of it. Like operators are solving the problems of GitOps and CI/CD, where Argo CD is like a declarative GitOps-based solution, which is sort of like continuous delivery tool that user uses to manage their deployments and all those stuff and make sure that the desired state is there from Git to clusters. Flux is again a similar solution in GitOps. Then controllers and operators are also solving the problems of multi-cluster and infrastructure orchestration. Like you see, Crossplane is one of the examples, which uses these controllers and it provisions the cloud resources like databases and all of those things, manages things around it. Karmada is again one of the similar examples as Crossplane, and Cluster API, which is again internal to Kubernetes, is also something doing the creation, scaling, and all those stuff. Operators are also in storage and data management, which is using Rook in itself, which does those things. Networking and service mesh, that is Istio. Also one of the projects where I was an LFX mentee, uses operators, and of course, the Cilium, storage and data management, almost everything uses an operator at core. So all these projects at some point is leveraging controllers to automate their reconciliation loops and ensuring that their actual state is equal to the desired state. But let's see one clear example of how it flows with, say, one of the examples, Crossplane. So I just came up with Crossplane because the architecture was very much easier to explain how operators are doing its job. So now that we have seen how simple controllers make your work, let's zoom out and look how the same controller model can scale up to solve extraordinary real-world problems. So today I'm here to talk about the architecture that represents the core ideas behind controllers, which is how controllers will watch, reconcile, and then act across complex environments. So this is Crossplane's architecture, and Crossplanes does not reinvent Kubernetes. It is just extending the existing solution and with additional CRDs and making more things like connecting with external cloud services like AWS, Azure, and all those things. So if you see the left side of this diagram, where developers are interacting with a Kubernetes, which is the CLIs and tools, developers and admins interact with Crossplane exactly as they do with Kubernetes, which is using CLI tools, kubectl, and client libraries, or even the user interface, that is the GUIs. Now that means you don't need tools or a different set of workflows to create operators and make operators work with your system. Now this controller includes specialized resource controllers. Now, like you see here, there is a custom resource controller, which is basically has a PostgreSQL instance in case of Crossplane, and then it reconciles data based on the information fetched from AWS, Azure, GCP, and things around it. So by exposing all of these cloud services and resources as CRDs, this particular controller is able to define everything in a simple YAML file or a JSON file, obviously, and version it in the Git and apply GitOps principles and GitOps automations to the deployments. So there is also a workload scheduler in this architecture, if you notice. This is also a part of this controller, which is basically intelligently placing these workloads across different clusters or clouds. That's the job of that particular controller. And the magic behind this particular architecture is that it is continuously reconciling the loop. As you see, the same pattern that we see in Kubernetes' core project is seen here. So if someone changes a resource directly in AWS, or someone changes a resource directly in, say, Google Cloud or Azure, this YAML file will basically detect that drift and then correct it, hence ensuring that the desired state is maintained. So honestly, this is so self-healing, and this is so cool that everything is just automated, everything is washed after, and you don't have to do anything. So controller is basically allowing this particular project, which is so famous right now, to act like a universal control plane, and it is also enforcing all of the policies and all of the things that you want, and into different environments as well, automatically. So obviously, since this is so interesting, do you not want to build one of your own controllers? Of course we do, because now that we have learned so much about controllers, that was some of the first things that I wanted to do when I realized the power of controllers. I also tried to build some controllers and do things around. But building controllers is definitely not that easy. So far we have seen how Kubernetes controllers powers everything from infrastructure to cloud to storage to networking and all of those things around. But how do we build one? So yeah, writing controllers by itself is super complex, of course, because as you see there on the screen, manually writing controllers is like writing so many stuffs. It's like writing Dockerfile, Makefile, managing dependencies, adding so many files like controller and all those things. But this can be sort of automated by some really cool operator frameworks that we'll come forward with. So yeah, but first let's understand what a controller does. So a controller initializes the API client, which is basically it handles authentication or any of the role-based access control stuff. It also monitors the API server, which is where it sets up the informers and watches, and changes to maintains local cache of the object state. Thirdly, it handles the events, which is like adding, updating, or deleting the events, or work queues, or rate limiting, and all of those things is done by the controller. And of course, the reconciliation loop that we've been talking about for this whole time. And glad we have operators framework, which is something that is going to help us build this controller and avoid all the mess that we had to create here, because manually writing it means defining your make file, which is basically having all the run commands, which will generate your YAML and CRDs and all of the other stuff. Dockerfile to build your operator's container image and all of those things. So let's see how operator frameworks helps us with that. So currently we have three different, in this presentation, I have chose 3 different operator frameworks which are really good. And we have operator SDK from a very long time, but now we also have KubeBuilder, and then there is also Meta Controller. So to talk about this real quick, KubeBuilder is like a general purpose controller development, which you can use any day just because you just woke up and you're like, oh God, this is so difficult to always keep looking at this part of my cluster. I'll just go build a controller that will do this job for me and I'm done. So it's as simple as that. KubeBuilder makes your things very much easy, but on a very ground level so that anyone can any day just build it. It's not very production ready stuff. On the other hand, operator SDK is more like it needs lifecycle management. So there is something called as OLM, which is operator lifecycle management, and it is highly used in production-ready software. So we can use that as well. And then there are meta controllers, which are very much like lightweight and very webhook-driven controllers. So you just add a webhook to your existing project, and you don't have to do the very heavy coding stuff, right? So we will be using KubeBuilder because it is like very fun to build, and it's like it scaffolds your controllers, and also it makes sure that your controller has all the best practices, and it is built on top of our very own controller runtime from Kubernetes, so it is best for custom controllers. Okay, moving on to KubeBuilder. So KubeBuilder, as I said, is very, very flexible, and it is widely used. So let's jump into scaffolding a real Kubernetes controller using KubeBuilder and see the magic. This would be a quick demo of how I have built so many controllers and how you all can just start building controllers and what all we have to do. So before getting started, we might need Go to be installed. It will be great if we have the latest version. We will need Docker for containerizing the controller. We'll need kubectl to obviously interact with Kubernetes. And then we can particularly start. I will quickly share my screen. Okay. Yeah, I think I have it here. So I have quickly recorded it, although if there are any doubts, I can particularly do it because it might take a lot of time. I was taking much time on my PC, so I wanted to avoid that overdue. Yeah. Okay, so this is controller. Let me. All right. Yeah, so this in this time we're gonna start with installing KubeBuilder first. So that is a simple command that I have used here to install KubeBuilder, which is doing the installation of KubeBuilder. I am trying to install the latest version of KubeBuilder. I just did it a while ago, so this is the most compatible way to do this demo. And then we are making it executable, of course, and moving KubeBuilder to my local binary. And from there, I would quickly So next step is I am creating a project. So when I say I create a project, I'm just creating a directory, project directory, and initializing KubeBuilder itself. So when I say that I'm initializing KubeBuilder, here I am initializing the project with the domain and the repository link, where it'll basically push all the scaffolding of my controller. Awesome. Once I have done this, once the creation of project is done, it was pretty quick. I created the API. So the Kubernetes the API code will be generated using the KubeBuilder create API command, which creates the API and links it seamlessly, which would have been very difficult without KubeBuilder. And there we use the KubeBuilder API command. I am creating the custom resources. I'm trying to create the controllers, entering yes, yes. And it just quickly does that for us. So this way we have the custom controller here. And now we're using the make command. So make is again something that helps us generate all the YAML files, generate all the CRDs and things like that. So we're using the make manifests to generate the manifests for this code. And as soon as we do that, we have things working, and there we have it. And now let's test the controller. We use a make install command to run the install command of this controller. I'll quickly go through the make version of it as well. And make run. So now this will keep running the controller in the background. If you see, it is basically running the main.go, which is the main page where controllers are situated. Awesome. Yeah, I think that was it. That's particularly how controllers work here, but I think it wasn't very clear, so I would take you directly to the thing that we have just created using these commands, which is this code. Okay, I think it's just running out of my screen. I will make it full screen and then shift it. Got you. Yeah, so there we have the code base of what KubeBuilder just did for me. So I will quickly run through what we have done in this demo and what has KubeBuilder done for us. So let me quickly come back here. Yes, so if you see here, there is a make file. Yeah, I'll rather come here. Okay, so we have a make file generated, which has all of those custom targets, like you see, make install, make target, all these things around. And we have a Docker file, which is again for building the operator's container images right over there, which is again generated directly by KubeBuilder. And we can obviously customize it later on, but the heavy lifting is already done. Then there is a main.go file, which is basically the main file that allows you to immediately launch your functional operators. But currently, it's like a no operational function operator, but you can obviously add your custom logic to it. And this file, the main.go file, is what will serve as the basic point where you start your operator to work. Then there is a configuration folder, which is again, that contains a lot of customized manifests. So what I mean by that is it is used to manage and deploy the operator's configuration. Then there is There's also a hack folder, which the makefile is obviously using, and it includes all the boilerplate source code, which is useful for inserting licenses and all those things. There is go.mod and go.sum, which is again dependency management, which is again done by KubeBuilder itself. There are CRD definitions, like KubeBuilder simplifies the creation and management of CRDs using the CRDs, as you see there. And there is a controller logic, which is a controller folder where you will be writing the logic for what you want KubeBuilder to do. Awesome. I think we have very less time, but I would quickly want to go through what we just saw. And this is obviously what we just saw right now, which is the process. And KubeBuilder is the most flexible and what we call it is a widely used thing. And this is what KubeBuilder is basically doing under the hood. What it just did was this diagram. Let me quickly. Yeah, it created the process, which is the main.go file. It set it up the manager, which is basically the controller to use the watching resources. And then we have controller, which is what you see on the screen as SIG-K8's controller runtime, which we're using, where each custom resource has its own controller. I just have 1 minute left, but I would really want to take this up. So we're using caching clients, reducing API calls, and doing all of these things. This is the architecture which this controller is following. The reconciler, which is, again, the reconciler library from Kubernetes, which is where the core logic goes. And webhooks. Webhooks, again, you can modify or validate resources using webhooks. And all of this entire architecture is done by KubeBuilder itself. A quick overview of Cargo, which is, again, one such similar project, which is Kubernetes native progressive delivery tool. And it also uses a similar architecture. So now, next time you ever go to any cloud native project, you'll find a similar architecture where there is API, where there is CMD, makefile, internals, and what is it exactly? It's a controller in hand. So I always have a saying that if you know the power of controllers and you always keep building controllers, at some point you will eventually end up building a big solution, which probably all of us will end up using, just like Argo CD came into existence, or Captain, and all of these projects came into existence. So Kubernetes controllers are not just about automating Kubernetes itself, but they are a way to automate the entire cloud natives ecosystem. And with the right idea and tools, you can build something that transforms how we operate in the cloud. So who is building next? That was it. That was for my talk. Thank you so much, everyone, for attending, and thank you so much.
Any questions?
First of all, very much thank you for your very enthusiastic and inspiring talk. So I really love that. One question, because you use now KubeBuilder actually to put out a lot of boilerplate code and that kind of stuff. My question actually was, where do you bring your own, in this case, logic to the mix? So you have this guestbook and that kind of stuff. Where do we actually define what the guestbook should do? So we define, in this case, the guestbook CRD, for example. Then we deploy the guestbook CR. Where goes the logic, in this case, to do something with that CR in your process?
Sorry, if I get your question correctly, where do you find the custom resource?
Yeah, no, actually, where do you put your own logic, in this case, to the mix? So the strategy actually to deploy it. So you deploy, in this case, a guestbook. That guestbook actually needs to result into something into the cluster.
Oh, yeah. So basically, the controller logic that goes inside the controller folder itself. So when I deployed the guestbook, what it created was a controller folder and a config folder. And the controller is where my actual logic will go inside. And the main.go will just take reference from controller. Main.go is just like the entry point. It links to the controller folder, and that is where your custom logic and everything goes inside of. So if I take example of another project like that I was showing, I don't think I have a Brave or, okay, yeah, we do. Yeah. There you go. So if you see, all the controller logic, internal logic, and everything goes inside the controller folder in itself, which is where you define the things. So we have a controller here, if I'm seeing correctly. And there we go. Was that the question? Yeah. Okay. Yeah. So I think KubeBuilder right now works only with Go language, but if you use operators SDK, that also works with Helm and Ansible, Go language, and there are also some operator builders for Python, things like that. For what? Oh, Rust. Yeah, so I think meta controllers can help with that. It helps you build your own webhooks, and that way you can use Rust and all those things. Yeah, thank you so much for your question.
Any more questions? No? Thank
That's
you.
really cool. I'll see you around at KubeCon, and thank you so much for attending my talk.